Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 9, Lesson 1 on the volume and surface area of prisms. So Unit 9 is generally about three-dimensional solids and how we measure their volume and their surface area, which you've obviously been doing for quite a few years now, both in Math 6, Math 7, and even prior to Math 6. In Math 8, we're going to be doing more sophisticated problems. We're going to be bringing in the Pythagorean Theorem. We're going to be bringing in knowledge that we have about circles and their circumferences and their areas and things like that, all of which, don't worry, we're going to review. But much of the math that we do in this unit is going to be quite messy, and every single lesson we're going to want our calculators on us. So make sure to have that handy, and let's get in and do a little bit of review in this lesson on volume and surface area of prisms. All right, now there are many important three-dimensional solids that we study in math, but one of the most important types is the prism. Now as a review, right, prisms are simply three-dimensional solids that have parallel polygon bases, okay? So their bases are polygons, and there's two of them, and they're parallel to each other, and they're identical, all right? All the other faces, known as the lateral faces, are parallelograms, and oftentimes they're not just parallelograms, but they're rectangles. So let's play around with a prism in exercise number 1 and review how we find both the volume and the surface area of prisms. A right rectangular prism is shown below. Answer the following questions. Letter A, what is the volume of this prism? All right, well, prisms are kind of interesting objects because the top of the prism and the bottom of the prism, if you will, the bases are identical. And any horizontal cross-section that you make of a prism will also be identical. Because of that, the volume of all prisms is simply given, whoops, got away from me. The volume is simply given by the base area times the height. All right, the base area times the height. And again, let's really quickly review why that is, right? The base area literally tells you how many cubes could sit on the base. The height then tells you how many layers of cubes you have. So the base of this is just this rectangle that's 12 inches this way and 8 inches that way. So the base is going to be 8 inches times 12 inches. And then the height is going to be 5 inches. So, you know, we're not going to spend time doing that longhand. We're just going to do 8 times 12. We could get our base area and write it down, but we don't need to. We can then just multiply by the height, and we find that our volume is 480. Make sure to get those units correct, cubic inches. Not inches, but cubic inches. And literally, right, what that means is that this object would contain 480 cubes that are 1 inch by 1 inch by 1 inch. And that's it. But all prisms, the volume can be found by finding the area of the base and multiplying it by the height. In terms of boxes, right rectangular prisms, that is simply length times width times height, which is a great formula to know. Now, let's start to investigate the surface area of this prism. Take a look at letter B. How many faces does this prism have? What kinds of shapes are they? All right, well, I'd like you to try to think about this. Now, the face of a prism is its side, right? So, you know, you got the face on the top, you got the face on the bottom, you got faces that wrap around. So what I'd like you to do is pause the video now, tell me how many faces we have, and what kind of shapes they are. All right, well, we don't have the hidden lines drawn in this picture, right? Those are those dashed lines that allow us to kind of see edges of the object that are hidden, all right? But we should still know that a box or a right rectangular prism has a face on the top, a face on the bottom, and 4 lateral faces that wrap around it for a total of 6 faces. Now, for a right rectangular prism, they are all rectangles, every single one of them. And then that makes finding the surface area of a prism relatively easy, all right? So let's take a look at letter C. Draw each of the distinct faces of this prism and label with the dimensions below. Find the area of each, then find the surface area. All right, so in other words, as we know, right, the surface area is simply the combined area of all the faces. Every face of a three-dimensional solid is itself two-dimensional and has an area. So if we can find the area of all 6 of the faces, then what we can do is find the total surface area. So what I'd like you to do is pause the video now, draw each of the distinct faces, find its surface area, remember there are going to be 6 of them, sum all of those areas, and get your final total surface area of the prism. Pause the video now and see if you can work through that. All right, well, one of the nice things about a box, a right rectangular prism, is that for every face there's an identical face on the opposite side. So for instance, talking about just the front of the prism, right, which is 5 inches tall and 12 inches wide, right, that rectangle, I could kind of draw like this, 5 inches by 12 inches. That's got an area of 60 square inches if I do 5 times 12. Now there's going to be 2 of those, but we'll deal with that in a moment. All right, now at the same time, right, we've got this face over here, which is still 5 inches tall and now 8 inches wide. So I can draw that, right, 5 inches tall, 8 inches wide, which has an area of 40 square inches. And finally, we've got the bases themselves, if you will, the top and the bottom, and those are 12 inches wide and 8 inches long, and when I multiply 12 and 8, I get 96 square inches. All right, now, keep in mind, every one of these, there are 2 of them. So I can now say that my surface area would be 2 times that 60 plus 2 times that 40 plus 2 times that 96, and let's take a look and see what we get. All right, again, no need to really do this longhand unless you want to get some workout with your multiplication and your addition. We're just going to do it on the calculator. All at once, we get 392. Keep in mind this is an area, square inches. 392 square inches. All right. Now the idea of surface area is very simple, right? You know, every solid, every prism or other types of solids that we look at are covered by 2-dimensional objects. Those 2-dimensional objects have areas that can be calculated. We simply need to add them all up. That's it. That's all surface area is, right? It's a property of a 3-dimensional solid, and yet it's 2-dimensional in nature because it has area and not volume. All right, let's play around with some additional prisms. That's all we're working with today. But now let's get away from the right rectangular prism and start to look at some other types. Now prisms are fairly simple 3-dimensional objects. We should be able to find their volumes and surface areas just using standard methods, right? So the volume and the surface area of any right prism, and a right prism is one where the sides, the lateral faces, are perpendicular to the bases. So it's not kind of like tilted in any way. And the volume of a right prism is always given, as we talked about, by the area of the base times the height, okay? And the surface area is simply the sum of the areas of all the sides, or all of its faces. Sorry, I shouldn't say sides. So let's look at one that's not a right rectangular prism, but a triangular prism. Exercise number 2. A right triangular prism is shown below. Its base is a right triangle whose legs are 3 centimeters and 4 centimeters in length. The height of the prism is 8 centimeters. Letter A, simple enough. What is the area of the base of the prism? All right, so the base of the prism, right, is this right triangle that is 4 centimeters this way and 3 centimeters that way, and it's a right triangle on top of that. So finding its area shouldn't be too difficult. Pause the video now and find the area of the base. All right, well, I don't love capital B as the area of the base, but that's what standard textbooks use. So we're going to say it's 1/2 the base times the height of that right triangle, and that's going to be 6 square centimeters. Now, if you don't see that, it's helpful to actually draw the right triangle kind of out like this, right? This is the way that base looks. And as we know, the area of any triangle is 1/2 base times height, but very nice when it's a right triangle because then the base and the height are both side lengths of that triangle. Now let's take a look at letter B. What is the volume of the prism? Well, this one should be a piece of cake, right? We know that the volume of the prism is the area of the base times the height of the prism. So using that knowledge, why don't you go ahead and calculate the volume of this prism? All right, well, we have our base area. It's 6 square centimeters. Literally 6 cubes could sit on that base, or maybe on that base. We've got the height. It's 8 centimeters. So here we go. The volume is the area of the base times the height. So that's going to be 6 times 8, and that's going to be 48 cubic centimeters. Oops, that really was supposed to be a 3, but it turned out looking like a 2. There we go. 48 cubic centimeters. Simple as that. All right, now of course we're going to turn our attention to the surface area. Now, as you're well aware, right, this thing is going to have, right, a number of faces. So let's first think about how many faces we have and what kinds of shapes they are. That's going to be letter C. Let's take a look. How many faces does the solid have? List the number and the type. All right, great. And maybe this should actually be a question mark instead of a period. So how many faces does the solid have? Why don't you go ahead and count them, list the number and the type. Pause the video now. Well, there are a total of 5 faces, right? There are the 2 identical triangular bases, and then there are the 3 lateral faces. So we have 5 total faces. Let me bring this up. Okay, so 2 are triangles. Those are my base faces. And 3 are rectangles. Right? All those lateral faces are rectangles, which we can pretty easily see, right? And it's because this is a right prism. All right, so now let's go to letter D. How can we find the missing width of the front face? Find its length, or maybe I should have said find its width. So let's talk about this a little bit, right? You know, we've got everything we need to calculate the surface area of this prism except for one thing. This shaded face on the front, right, we know its height is 8 centimeters, but what we don't know is that length, right? We have no idea what that dimension is. So think about how you can find it and then see if you can actually calculate it. Pause the video now. Well, let's draw that base one more time, right? What we've got is we've got this triangle, and what we're missing is that side length, and we need it, right? We've got to have that or there will be no way of calculating the area of that front shaded face. But this takes us back to the last unit, right? Our last unit was on the Pythagorean Theorem. And the Pythagorean Theorem will always help us find the length of a missing side of a right triangle if we've got the other 2, right? So we can find that using the Pythagorean Theorem. All right, and specifically in this case, we're looking for the hypotenuse. Right? That's what we're missing. We're missing the hypotenuse, so I'll call that C. So I'm going to just do a little 3 squared plus 4 squared is equal to C squared. 9 plus 16 is equal to C squared. C squared is equal to 25. C is equal to the square root of 25, which is equal to 5 centimeters. Let's draw that actually on our picture, 5 centimeters. Now, I'm kind of hoping that at some point you will have seen the 3, 4, 5 right triangle enough that you don't even need to do the Pythagorean Theorem. You just know, hey, I've got a right triangle, 2 of its legs are 3 and 4, so its hypotenuse has to be 5. But if that isn't, if you don't recognize that Pythagorean triple, as we called it in the last unit, feel free to use the Pythagorean Theorem. But you have to recognize, I got to use that theorem to find it. All right, now let's get that surface area. Let's take a look at letter E. Draw each face below, find its area, and then find the total surface area. All right, awesome. I'm going to just bring this up a little bit. Try to bring it up a little bit. I'd like you to go ahead. Let's put that 5 centimeters in here right now. Make sure to have that labeled on your diagram. Okay, what I'd like you to do is draw each one of those 5 shapes, calculate its area, sum them all up, and find the surface area of this solid. All right, let's do it. Well, I might start with those 2 identical triangles, right? So I've got my one triangle, that's 3, 4. I do have the 5 here, but I don't really need it. That area is going to be 1/2 base times height. We already figured that out. That's 6 square centimeters. There's 2 of those, so just so I don't forget them, maybe I'll do this, and also 6 square centimeters. No need to write the calculation again. Now I've got my 3 rectangles. One of the rectangles is 8 centimeters tall and 3 centimeters wide. So its area, its area is going to be 24 square centimeters. I've got another rectangle that is 8 centimeters high and 4 centimeters wide, and it's going to have an area of 32 square centimeters. And finally, using all my available space, I've got a rectangle that's 8 centimeters high, 5 centimeters wide, so it's got an area of 40 square centimeters. Let's just circle all of these so I don't forget any of them, and then let's add them all up. Okay, what do we have? We've got a 6, another 6, a 24, a 32, and a 40, and we have, at the end of the day, a surface area of 108 square centimeters. All right. And that's it, right? Surface area calculations can be lengthy. Let's be honest about it, right? Because oftentimes prisms have multiple faces, and you got to find the area of every one of them. You got to be careful doing that, and then you've got to add them all up. It's interesting because comparatively, right, finding the volume of a solid is relatively easy. I have to find one area, i.e. the area of the base, and then I have to multiply it by the height. This is for prisms, that is. We'll get into other figures eventually in this unit. But for prisms, calculate an area, multiply it by a height, and you have a volume. Compare that to this, where I had to calculate 5 different, well, 2 areas that are the same, and then 3 areas that were different, and then add them all up to get that 108 square centimeter surface area. All right, let's look at one final problem, thankfully only involving volume. Let's take a look. Now, the Pythagorean Theorem is going to show up all over the place in this unit, and you should be ready to use it whenever you're sort of missing a length, right? If you're missing some kind of dimension that you need, think to yourself, could the Pythagorean Theorem help me? Right? And it can be helpful in all sorts of contexts and in all sorts of problems that we couldn't have solved before. And let's take a look at one final example of that in exercise number 3. A prism has equilateral triangles with side lengths of 4 inches as its base. Its length is 10 inches as shown. Use the Pythagorean theorem to find the height of the equilateral triangle to the nearest hundredth of an inch. All right, so let's just be very clear about why this is a prism. We're used to seeing prisms, as we did in problems 1 and 2, that are literally sitting on their bases, right? In this case, that's not the case. We got a base here, which is an equilateral triangle, a base over here, which is an equilateral triangle, and then we have these rectangles as the lateral faces. So this really is the base, this equilateral triangle, and the 10, if you will, is the height of the prism. It's not really the height, right? It's the distance between the 2 bases, and that's what's important when you calculate the volume. But the first thing I gotta figure out, I have to figure out the height of that equilateral triangle if I have any hope of calculating its area. I can't calculate the area of this equilateral triangle by doing like 4 times 4 and dividing by 2, right? That's not gonna work. But see if you can use the Pythagorean theorem to figure out the height of this equilateral triangle. And maybe let's like throw all those in. What I really need is I need to know that height. So pause the video now and see if you can use the Pythagorean theorem to come up with that height. Shoot, I mislabeled that picture. I apologize. It's not supposed to be 10 each one here. Those are all the 4s. The 10 is over here. Let me get rid of that so that we don't get the completely wrong height for that equilateral triangle. Let's try that again. 4, 4, and 4. All right. Now pause the video and see if you can find that height. All right. Now, one of the things that's a little bit tricky about this particular Pythagorean theorem problem is you have to realize that the right triangle that you're working with is actually this triangle, right? In other words, right, when we take that height and we drop it down, it's going to cut this base in half so that there's only 2 inches here, and then the hypotenuse is 4 inches. Keep in mind that what we're now solving for is one of the legs. It's either the A or the B. It doesn't really matter. But I can now say h squared plus 2 squared is equal to 4 squared. That gives me h squared plus 4 is equal to 16. H squared is equal to 12, and h is equal to the square root of 12. 12 is not a perfect square, and therefore its square root will be an irrational number, right? A number that never terminates, never repeats. But this asks us to round it to the nearest hundredth of an inch, 3.46 inches. All right, that seems accurate enough, definitely. Now, we're going to use that 3.46 inches for the rest of the problem as the height of that triangle. Even though we've rounded it, we're going to continue to use that. We'll talk more about rounding as this unit goes on and the problems get even messier, believe it or not, than this one. But for right now, we're just going to stick with that 3.46. All right, now simple enough. In order to find the volume of this object, we're going to have the area of that base, but that should be relatively easy now, and let's take a look at letter B. Find the area of the base of the prism. All right, great. Well, it's a triangle. You know that the base of the base is 4 inches. You know its height is 3.46 inches. So now, why don't you go ahead and find the area of that equilateral triangle. All right, well, I just got to find the area of that triangle. That's sort of my big B, if you will. That's going to be 1/2 times 4 times 3.46. All right, let's bring our calculator out. 1/2 times 4 times 3.46 gives me an area of 6.92 square inches. All right, great. And we're almost there. Now we can find the volume. Letter C. Find the volume of the prism. All right, you could probably almost do this one in your head. Pause the video now and come up with the volume of that prism. Well, the volume of any prism, as always, is the area of its base times the distance between those 2 parallel bases. So it's just going to be our 6.92 square inches times that 10 inches. All right, so V equals B times H. In this case, the H is that 10 inches, so 6.92 times 10, which is 69.2 cubic inches. And that's it. Now, this problem, by the way, is not significantly different from the last one, right? The biggest difference is when finding the volume of this particular prism versus the last one, right? The last one also had a triangular base, but its triangular base was a right triangle, so it was very easy to find the area of the base. This one, the area of the base, was much more challenging to find because we first had to use the Pythagorean theorem in order to find the height of that equilateral triangle. And once we had that height, we could then find the area of the base. And once we had the area of the base, we could find the volume of the prism, right? But it gets more sophisticated, right? You're not in Math 6 anymore. You're in Math 8. So you have to use more of these tools that you've developed over the years in order to find that volume. All right, let's wrap this up. Now, prisms, which is what we looked at today, are some of the most simple solids out there, right? They're simple because their two bases are identical and parallel. Most of the time when we deal with prisms, we deal with right prisms, which means all the lateral faces are not only parallelograms, but they're actually rectangles. All right. The volume becomes very easy for a prism because it is simply calculating the base area, the area of that base, and multiplying it by the height of the prism. Or, thinking about it a different way, multiplying it by the distance between the two parallel bases. Now, surface area, that is what it is, right? That's finding the area of each one of the faces, regardless of whether it's a prism, a pyramid, or anything else, and adding them all together. That can be quite a challenge. But we're going to let our calculators do most of the messy work on these problems. Primarily, we just have to know our area and volume formulas, as well as how to use our calculator to sum and multiply all the various pieces of information. All right, we'll see certainly more prisms as we move through this unit, but the important ideas are really what we got at today in our review. Thank you again for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.